And I'm presenting the final NBA player development projection project. We began by just using some simple import statements to get all of the required libraries, including things like pandas, sklearn, and the basketball reference scraper API. And then we set global variables, including the create datasets, which I set to false because I've already created the datasets on my local machine. And then the start year and end year determine how much data you want to pull into memory and how far back you want to go, so that could change depending on which players you're projecting. I'm going to start by running that cell. Next, this is where the data set for the entire NBA season is created. Since I have create datasets to false, it's not going to create anything. But here's an example of the 2021 season. So as you can see, it has every player in the NBA. And additionally, it has all of the per game totals, all of the per minute totals, all of the per possession totals, and then all of the advanced stats. Next, the cell breaks down the overall NBA data frame into positional data frames. And it also removes columns that cannot be used in the model, including things like player names, teams, and other strings. So as you can see, here's an output of all the data frames, which include each position for each year. So we have 5 positions and 16 years, which means that we're going to have a lot of data frames loaded into the local memory. Here's an example of one of those positional data frames for the 2021 season after the K-Meteoroids model has been run on it. As you can see, there are clusters of similar players. Usually the groupings are 10 plus players, but sometimes you end up with groupings that are much smaller. This one, which makes sense because all of these players are extremely comparable. This is the cell where those models are being built, and then the data frames are being saved to CSV if you have that create datasets global variable equal to true. As you can see, it's building the models for each individual season, and the models are relatively quick. Next, you input a specific player that you're looking for to project, and then the player's position. In this case, Zach LaVine is a shooting guard, which is position 1. And the season that we're taking to project his future growth on is 2016. And then lastly, this age difference variable tells you how many years you're going to be projecting for. And that's also going to filter players out who aren't 5 years older at least, because they won't have 5 comparable seasons to project off of. And the basketball reference API, the basketball reference scraper API, requires you to input like a validation for the player because there are similar players with similar names. Next, once we have the data frames with all of the similar veterans, we're going to filter out all of the players who do not meet the age requirements, and then we're going to filter the data frames by age and remove the trade seasons where a player has multiple seasons in the same year because they've been traded. So we take the total statistic, and then remove players with injured seasons who impact the model output. And then we also go and find the best and worst PER index to give us an idea of which index will provide the best and worst projection, although that does not always turn out to be the case. So as we can see, we get 4 total comparable veterans after all of the filtering, the best PER index being the first, and then the worst being the 0th index. In this case, I believe that the worst player is Avery Bradley. And then this would be the best player per PER. And this output shows us the stats that are going to be compared to Zach LaVine's base year. So next we create the projection for the target. So we get the base year of the target here, and then we also calculate the percentage increase by season for each of the veterans. And then we find the veteran at the same age. We calculate the raw difference between their statistics and make adjustments to the base year. And then we project out each following year using the percentage increases. And then we return the projection. So our average projection function is going to run this get target projection function over all of the veterans that are listed in comparable players. So here's an output for the average projections. So points per game, we have scaling from 23 to 36 in his 5th year. Or sorry, from 14 to 36 in his 5th year. And then field goal percentage, we have scaling from 45 to 45 as well, so relatively flat. And then total rebounds scaling from 2.8 to 5.2. Next, we're going to use this display function, which should display the outputs of some of our base statistics, including points, total rebounds, assists, field goal percentage, and PER. And more variables can be added to that if needed. So, as you can see, the blue line representing the player's stats, or the projection, and the orange line representing the player's stats. So the projection has him increasing his point totals quicker than he did in real life. And in comparison, his total rebounds are actually relatively similar. His assists are projected to increase a lot quicker as well, although in the end he reaches kind of a similar point. His field goal percentage is relatively similar throughout. And then his PER as well is projected to be higher than it is in reality over the next kind of 5 years. Again, but ending at a relatively similar point.